Sure, I'll answer that in just a second. Let's begin with a word of prayer. Dear Father, we thank you for this day, and thank you for the students. Just ask you to bless this time we have, just to clarify any questions that remain about this class. Amen. So, you had a question about the grade, you said? Like what I did to grade book, or?
Yeah, so
yeah.
I added up points. Things they were like, there's a lot of history like in the 500s, but I added up all the points that you gave us, and it should be like...
Ah, yes. Well, that's because points are not points. So, points are not points in the following sense. So, your homework points and the syllabus, like the you've got 200 points for homework and the syllabus, right? But unfortunately, the MyLab problems, the way they come, they're weighted with the points in the MyLab problems add up to 370. So what you have to do is you have to take 200 times the MyLab points and then divide by 370, and that's equal to your homework total. Yeah, if you have 370 homework points altogether, you got 200 points in the homework total column. So I need a column in the grade book that's homework total. That's the actual number of points that you've earned from homework. As of the time I made that, I haven't updated it yet, right? Like I have to, I have to download the grades from Gradebook and then run it through Excel and then upload them again to refresh that column. It's not done inside Canvas. Now, once we're past the final due date for the homework, I'll refresh it, and then you'll know like your final, how many points you earned in homework for the semester. Up to a point. It's like up till when I made the announcement about adjusting the gradebook, that's when it happened. Like it's just a snapshot till then. So if you want to know actually how many points you have in the homework total currently, you can do what you're doing, which is just add all the entries up where you have homework, all like 10 of them or whatever, and divide by 370, multiply by 200. That'll tell you the number of points. You have at least that many points. If you did more homework, after I posted that column, then sure you have more points, right? So there's that. The other thing is the modified test total, right? So that's empty right now, right? But what will go there is like this. It's going to be 150. I mean, you'll never see this, but this is how I make the number there. 150 times the max of like test 1 divided by 150, or the final, divided by 200, and then plus same for test 2, plus the same for test 3. So, for example, if you make 100% on the final, right, then your modified test total column would work out to 450. If you make 90% on the final, right, but you made 100% on some of your tests, then what's going to happen? Then some of your tests are going to get counted as the max, and whatever test you have under 90% is going to get replaced. So this is how I replace your test grades with your final exam score if it's helpful. I have to weight them, right? Because the final is 200 points, whereas your tests are 150. So, I have to like divide by these numbers to make it a fair comparison. But this essentially gives me the percentage. Percentage divided by 100, I guess. But anyway, so this I can't populate that column until after you guys are done. After I'm done grading the final, right? And then like the other points that are there right now. So somebody asked me, I told another person who asked about this. I'm like, well, everyone at the moment is probably failing the course. Now, I think that may not be true for you guys, technically speaking, because the total points. Well, here's the thing: the total points. That's the other column, right? Total points. What does that mean? It's not up to date, yeah. So that's a snapshot. It's everything up to, but not including test 3 and the final. And homework you did. Basically this week. Because I haven't updated that homework total. Like once I update the homework total, then I'll update the total points. So because I have tried to make the final column in Canvas appear as total points because that's what's important. Percentage doesn't mean anything. We have a 1,000-point scale. The important point is how many points have you earned, right? Your total points, that is the minimum number of points you've earned, right? You've earned more because you've taken test 3, you earned some points for that, right? In fact, now you know what that is because you can go to the gradebook and you can add that to your total points, right? But for some of you, hopefully, your final exam will replace test 3, right? Notice that I will replace not 1, not 2, but up to 3 test grades with your final exam score if it's helpful to you. There are other sections and other classes where they just replace 1 test. In fact, that's kind of the usual thing here. So this is like more generous than typical around here, yeah? I don't know, people have different philosophies for why they do or not or don't do that. I do it because I think it's important what you leave the course with more than what you have, and everybody has a bad day. Some people have 2 bad days in a semester, right? But I mean, you have to have a good day at some point for me to give you a good grade, but hopefully that day is the final for you. And anyway, so I will refresh the homework total column, and obviously the max text total column, and also the total points column as soon as I've graded the final. Maybe before then. I had a student in another section ask me to tell her what grade she needed to make on the final in order to earn, maybe it was one of you guys, I forget which section this person's from, to earn a C in the course. And I said, well, that's an interesting question. That's actually kind of a complicated calculation because in order to answer the question, what does it take for you to make a C in the course, I have to think about what the status is of your test grades and figure out which one, at what threshold do you start replacing your test grade with your final exam grade instead, you know? So it's a kind of complicated question to figure out what you need technically on the final to make a C in the course given how I've announced the grading system, right? Because it's case-wise. There's not just a formula for it, right? I can't just solve an algebra equation straight away. But I'd like to figure out that question for that student, and if I figure it out for that one student, I might as well figure it out for everybody. And so once I do that, I'll probably post an additional column in the grade book, which is like grade you need to earn a C in the course. A grade on the final to earn a C. And if I'm answering that question, I probably should also add a column, grade you need to earn on the final to earn a B, right? And probably if I'm answering that question, I probably also need to add a column, grade you need to earn on the final to earn an A, right? Is that possible for everybody to earn an A? Sometimes it's a little bit complicated because maybe not. See, because the homework total is 200 points, right? So if you're a person who's only done 25% of the homework, you have made the ceiling of your grade a B. See, that's 200 points. If you lose 150 points here, you can't fix that with the final. I don't make the final cover up homeworks. Final only covers up bad test grades. Homework's up to you guys. Like that stays there. So whatever points you lose on the homework, you've lost. Like those are not fixable. And the same for like quizzes and participation. Now you guys have like pretty much perfect participation scores, and your quiz scores, well, they're not awesome. They're not like the death of your grade, right? Because quizzes are only 90 points, and most of you have at least like a half. You've only lost maybe 30, 40 points on quizzes, most people, right? So, but my point to you is, if you've lost more than 100 points in the homework, quiz, participation category, then technically speaking, you can't earn an A, right? And I think that's a reasonable thing to say. However, if I put bonus points on the final, then that changes the equation a little bit too. So, and I do usually do that. Like, my final usually has like 10% bonus. Now, is it easy to earn 110% on my final? Not really. And probably the person who will do that is a person who already has all the points in the course anyway. So it's kind of fun. Anyway, so enough about the grading. Yeah, question?
So like, what if like you have like only like 2 points off of like the homework, but then you struggle a little bit like with the test grades and stuff, like you're in like the C-ish range? Like, how would you calculate that?
Like I said, it's complicated because the question is, at what point? Well, I mean, I guess it doesn't have to be complicated. If your test grades are really, really bad, in the sense that, you know, they're like 60% or lower, let's say, something like that, and then probably you can just assume that your final exam has to replace those in order for you to make the grade you want, right? So let's see here. A quick estimate would be you take the, let's say you want to make a C, right? Let's say you want to make a C. I'm not saying you want to make a C, I'm just saying in principle. So if we take 700 minus the total points as they exist, 700 minus the total points as they exist in the grade center, then that tells you how many more points you need to earn, including what? Including like test 3 in the final, right? So some of you got like 500 points already, right? Like a lot of people have 400 to 600 points, I think. I forget, like the scores vary from quite a bit, but my point to you is whatever that difference is, you need to make that up, right? So you already know what you made on test 3 because you can look in Grade Center, right? So if that's a good score, then you keep it, right? And then what? Whatever that leaves you with, that's how many more points you need to earn, right? And you can either earn those points just directly from the final, right? Yeah. But if you earn more, the thing is with the final, it may be like earning 180 points on the final will make this thing kick in, so you'll get more points from this, essentially, right? Like at some point, if your final exam grade is high enough, you start fixing bad test grades from before. That's the thing I can't explain succinctly. But anyway, so like this, I mean, like a really quick estimate would be 700 minus total test points, minus total points, and then you can do what? You can add your test 3 score, right? That gives you a kind of quick lower bound, but that may be pessimistic because if your previous test grade was really low, then whatever that is, like let's suppose that you made, just for the sake of discussion, let's suppose your total points was 450. There are some people like that in here, right? So suppose you made 450. And then 450 total points, right? And then suppose your test 3, let's be like pretty pessimistic, well, kind of medium pessimism. Suppose you had 100 points on test 3, just for the sake of my arithmetic being easy. So then what would you have to make on the final? I believe that's, what is that?
How many points are on the final?
200. 200 required points. There may be some bonus. Let's see here. It's 3, 250, 150. So this would be 150, right? So if you made a raw score of 150 on the final, then you'd have a C. That would be a 75 on the final. But this is actually somewhat pessimistic because if you had a 450 total, you probably had less than a 75% on one of your tests, right? Which means if you make that 150, you're actually going to get more points than that because you're going to be you're going to be adding points from replacing your earlier test grade too. This is why I have to use Excel to answer that question for everybody. I'm not sure I'm going to be able, I'm going to try. It's a complicated calculation for me to answer for everybody at once. Like one of you, I can sit and fiddle with your numbers for 10 minutes and give you an answer, but I have 100 students, so I better figure out how to do it all at once, yeah. Okay, enough about I hope I've made that somewhat more clear. The bottom line is you want to do the best you can on the final, right? I mean, that's not surprising. So how do you do well in the final? I think the smart thing to do is to like study all of the old quizzes and all the old tests, right? I have posted a blank copy and the solution for all of them, right? So you can go back, you can try to work it again for yourself and then find out where you go wrong. Let me just start with the solution to test 3. I'm trying to let you guys go a little bit early today, so let me move along here. I can. So any questions about problem number 1? Just make sense to you guys? So, here's the way I think about it. This, if I look at it, the center of the circle is where x is equal to 0, which forces it to be this one. This one has a vertical asymptote of -2, which forces it to be this one. This is a circle centered at 2 minus 2, which forces it to be that one. And this right here has a horizontal asymptote of -4, which pretty much forces it to be that one. And of course you could say more, but that's essentially it. Now most people at this point are getting this question right, something like 80–90% of the class. And I think the same is true for problem 2. A lot of people are getting problem 2 right now. A lot of people got this wrong on the quiz, more or less, but basically the thing here, if you haven't gotten it yet, is you need to complete the square. Now people who got this wrong, you're not completing the square right, like you're adding 100, or you're like, some of you like added 100, but you subtracted 9, or some kind of, like you're unstable in terms of whether or not you're adding or subtracting into completing the square, but we subtract the square of the number that we put inside the square, right? So I subtract 100, I subtract 9, I add it to the other side, I get 121. The square root of that is 11. So there's that one. There's a lot of improvement for problem 3, but there's some of you who still have a ways to go here. I will tell you the most popular mistake. The popular mistake is people get about right to here, and then they go, wait a minute, what was I doing? And then you have this unfortunate thought, which is, I should solve for y. And then if you get about here, and then you decide to solve for y, where does that take you? It doesn't take you forward, it takes you back to here. Right? And some of you have done that. You've gone full circle. You tried to solve for x in the middle, you forgot what you're doing, and you solve for y, which gives you the wrong answer, right? You have to solve for x, and that right there is the formula for the inverse function. Yeah. What? Yeah. Oh, it's fine. And then like a lot of you lost like a point or two because you made some like sign error somewhere down here, like dealing with the minus and how it irons out there. There's, yeah. Very significant improvement on this problem. Most people have this right or close to right. If I took a point off, it's just because your inverse graph it's the right spirit of things, but it's not quite there. If I took off 3 points for the graph here, that means you're pretty far off. But yeah. And so problem 5, the answer was 42. Exponentiate both sides base 2. You have 2 to the 5th, which is 32. There is a subcurrent of students that make this 5 to the 5 squared, which is unfortunate, but wrong. Yeah, and then here, problem 6, when we take the log of both sides, we've got log of 100. Now log of 100 is log of 10 squared, which is 2. Of course, you could also use your calculator to figure this out, that it's 2. A lot of you have put like a 10 here, or a 5, or any number of weird things, but just not 2, unfortunately. So anyway, when you do it this way, you get x squared equals to 9, and then you get, and a lot of you put 3 here. And some of you even got plus or minus 3, and then you're like, something's wrong here. One of these must be extraneous. I'm going to rule it out, right? Which is unfortunate because these are not extraneous. Like if you plug minus 3 back up into here, you get minus 3 squared, which is 9. 9 minus 7 is 2. 10 to the 2 is 100. It works. Plus and minus 3 are both solutions here. Just because it's negative doesn't mean it's necessarily extraneous. Now that will happen later, that the negative solution is extraneous, but not here. I don't have anything to say about this because almost everybody got this problem right. If you got this problem wrong, it's probably an arithmetic mistake. It may be that you still don't have a clear path in your mind. Like, look at how little I wrote. I have a lot of people who wrote like this whole area full of stuff, right? And then there's no need for that. You just have to have a clear path. What are you doing? Just take the second equation, solve for y, and then substitute that into the first equation. That will give you one equation and one unknown, which you can solve. Don't make it more complicated than that, right? Or you could add equations if the pattern was nicer, but this pattern is not nice. It doesn't yield itself to elimination. It yields itself to substitution. Oh, there's a lot of badness in these two problems. Let me start with problem 8. So we have, bring the square in, we get log of x squared. This 1/2 gives me natural log of the square root of y plus 1. and then we get minus log z. Then I put it together. I have x squared times the square root. And then since I have subtraction here, I have division there. All right, and it should be natural log of the whole thing. Some of you have like natural log of the top divided by z. I think there's somebody somewhere who has like natural log of the top divided by the natural log of z. I can see that you studied, your heart's in the right place, but it just didn't quite translate right? Like this is what it should look like. So it's mostly the case that you guys need to work a little bit more on the log properties. You haven't quite got them yet. As a class, I would say that's statistically true. And there are some people in here who are like rock solid on it. I've got about 5 people overall who got this problem right. This is pretty rare for people to get that right. Some people got to here, which is good. That was more like the quiz, right? So log of 1,000 plus log of x plus log of y squared plus log of z cubed is this, because I can pull the 2 out and the 3 out, right? But notice that a, b, and c are natural logs. So technically, to get to a, b, and c, I have to use change of base formula, which demands that I divide by log of 10, because these are log base 10s. So if you didn't get this, like I just took 2 points off, not too much there, but that is the correct answer in this problem. Problem 10, a lot of people have like c over 2. Not sure how that happened exactly, but it's not a logical consequence of like the laws of logs. You have to get square root there. If you bring the half in, you get log of square root, log to the c to the 1/2. And then the 1-to-1 property gives me a minus b is equal to root c, which then gives you this. So a lot of people are very wrong on this problem, and for a variety of reasons. I think about half the class got problem 11 right. A lot of people get to here, but then don't finish well. I'm not sure exactly what happens. Maybe it's a calculator issue. But yeah, it works out to 2.310. Let's see here. A common and really, really conceptually flawed step that I see it and I tick off 7, period, is if you put a 6 here. This is not reasonable. You're trying to find the time, t, for which you get 6 as an output. You don't put 6 as an input there. That does not make sense. So a lot of you have started like that. When you start like that, everything you write after that's just like, you're spinning your wheels. It's not, I don't know, it's everything after that's not going to be productive for you, unfortunately. But anyways, you're trying to find the time which makes this true, and then you work that out. In some sense, problem 11 is important because that's one of the more common kind of equations that's found in applications, right? Especially ones that require this class as a prerequisite, like say, maybe chemistry or something like that, or a science course where you have exponentials. This one here, remember that the log of a sum, the sum of the logs is the log of the product. So we have to have a log of the multiplication of the inputs. So that's the way that has to go. And then that gives us this quadratic equation, which is actually x squared equals to 4, which gives us 2 or minus 2. Now some of you got lucky. You just didn't even put the minus 2 down, right? So some of you didn't try to tempt yourself with minus 2. You just didn't even look at it. And it so happens that you got full credit, right? But be careful. If you didn't put minus 2 down here, you're not quite thinking clearly about the plus or minus nature of the quadratic, yeah? But I didn't want to take points away from you because I've taken enough points in other problems. Now here, the minus 2 is extraneous because if I plug minus 2 into the given equation, I get logs of negative numbers, which it's not allowed. Oops. Let's see here. And yeah, I know it's complicated because the copier jammed when I was making your test 3, right? So some of you have page 3, then page 4. Some of you have page 4, then page 3. So you'll find it. Hey, a lot of people got c equals to 4, which was wonderful. Like that is easy picking, and everybody should have that, and most people did. So that's great. And then I have to plug the 2 points in. I get 2 equations, and it works out to b being minus 1 and a being 2. And some people got this, but a lot of people have like an 8 here and a 4 here. I'm not sure how that happens exactly, but there's a lot of agreement on the wrong answer. Listen, so on the final, maybe you have a little bit more time overall, right? So if you have your if you don't get stuck on anything and like burn a half hour of your final time, right? If you actually have 20 minutes left, if you get to the end, you're like, oh, I still have 20 minutes left. What could you do with that time? A smart thing you could do would be to go to problems like this and check your answer, right? It's not a hard thing to check the answer on these problems, and it'll save you a lot of points, right? Or it could potentially save you a lot of points. So if I try, for this one example, if I put 2 in, what happens? F of 2 is 2 times 2 squared, which is 8. 8 minus 2, 6. 6 plus 4, 10. Is that what it's supposed to be? It is, right? What happens when I plug in minus 2? Plug in minus 2. I get 2 times minus 2 squared, which is 2 times 4, which is 8. 8 minus a minus 2 is 10. 10 plus 4, 14. Is that what it's supposed to be? It is, right? So, especially for problem 13 and problem 14, you can check your answer, right? Now, there is a subclass of you who are wise to my games, and you're like, I don't need to learn algebra because Dr. Cook's always just going to give me numbers like 1, 2, and 3 for answers, so why learn algebra when I can just plug numbers in? See, now that I've become aware of this trend, you should be worried, right? Because what happens when I make the numbers bigger than 1, 2, and 3 as answers? Then your method, it doesn't work so good, does it? So I wouldn't assume necessarily on the final that the answers to everything are nice whole numbers, which are, 1, 2, and 3, and stuff like that. Like I would like for you guys to learn the method rather than just guessing. I am impressed that you have managed to guess the answer here, in some sense, but and this is like the homework problem we worked in class, right? Like the first one we did, the easy one. Remember, we added the last 2 equations and stuff just canceled, and we immediately found x. And then once you have that, then that allows you to do 2 equations and 2 unknowns, which we can solve in the way we did before, which, by elimination or by substitution, whatever looks prettier. So I will tell you this. I think if I was to put a problem like this on the final exam, it's very likely that it has the same kind of pattern that I've already emphasized in the test, right? And also in the lecture. Now, if I wanted to be a jerk, I'd give you one of the problems that requires you to use the 3-step substitution process for 3 equations and 3 unknowns, right? But it's almost time for Christmas, so it's much more likely that this is the kind of pattern that you'll see on the final. Different numbers, similar pattern, yeah? What am I getting at? I'm trying to get at, you should think about adding the second and third equations of the system of 3 equations if I give you one, because that might be very helpful. Any questions? All right, well, let me go back to test 1. Go back to test 1 and just make a few comments there. I'll try to be brief. So to be real brief, factoring, right? We did factoring. Now what should you do here? Don't look at these too hard, right? What you want to do is get out the blank copy of test 1 and the blank copy of quiz 1 and try to do the factoring on it. See if you can do it. Because if you can't do it, you need to work on that because it will be on the final, and not being able to factor it's just something that will continue to plague you everywhere else in the course on the final. So like factoring is important. A lot of you lost a lot of points here, right? So you want to figure out if you can fix that, yep. So that's number 1. Number 2 is if you're a person who lost a lot of points on the factoring, right? After you practice, right? The next thing you should do is to copy down all of these examples onto your formula sheet so that you have a bank of examples to go off of. If you get stuck on a factoring problem, if you're just like, I don't even know, what even is this, right? Well, maybe you can look at one of your examples if you're stumped and you can go, wait a minute, so this one had this x to the 4th, it had x squared everywhere. The first thing we did was to factor x squared out, right? That was a productive step. So maybe if you have a bank of examples on your formula sheet, in case you get stuck, it could be kind of a lifeline to you, right? That's part of the reason I give you the formula sheet, is so that you can add examples of the particular thing you feel like you're weakest on, right? But you got to do the work to figure out what you're weak on. You can't just have everything on the sheet, right? Unless you write really tiny. But you are allowed three sheets, right, front and back. So make use of that, but use it wisely. Certainly putting the examples on the sheet is not the same as like studying, right? That's part of studying, but it's not a magic cure for getting these problems wrong, right? Because the numbers are going to be different. The patterns might even be different for factoring. But certainly what you see happening in these examples and also on quiz 1, they should be helpful to you. How about this right here? Can you guys tell me what's the vertex of the parabola defined by y equals 2x squared? What's the vertex of the parabola defined there? I haven't defined it yet, but so if I write y equals to 2x squared plus 8x minus 14, where's the vertex? Can you tell me? Looking at what's up here, can you tell me? I'll start the ball rolling. Some people in the last class told me it was at -2, -11. What do you think about that? They were looking at this, right? Nope. That's not the problem. So the problem is this. The vertex form for the parabola, and that, by the way, here's something that should be on your sheet, right? Is x minus h squared plus k, right? Vertex at h comma k, right? K is equal to what? K is equal to f of h, by the way. So if this thing is f of x. So what's wrong with my alleged vertex? Like look at the formula. Do you see what's wrong with it? See where the parentheses are? Do you see where the parentheses are? They're not where they belong, right? There's no parentheses here. A just multiplies that term. K sits out here on its own. See, so the vertex form is related, but it's slightly different. See, because you have to multiply the 2 through to see that the vertex is not at -11. No, it's at -22. So completing the square is helpful, right? But you have to be aware that there's some wrinkles here. Like if you want to see the vertex, if you have a number factored out, you have to multiply it through in order to see where the y coordinate of the vertex is. Now the square, that reveals that -2 is where the x, where the x coordinate is of the vertex. That's fine, right? And then if you think about plugging in, if you actually think about taking -2 and plugging it into the formula, right? What happens when you plug -2 into the formula here? This becomes 0, right? And you get 2 times -11, which is -22. So there's various ways of seeing this, but I just mentioned that. I mentioned that to be fair to you guys because I've mentioned it to other sections. So again, I'll try to be brief. We have talked about these things earlier in the course. Just want to remind you, the final is comprehensive, so there might be questions about like simplifying rational expressions. Remember, to divide an expression is to multiply by the reciprocal. The general point of order here, make common denominators, look for canceling things if you can, right? When you're calculating solutions to a quadratic equation, if you've got the square already sitting there, we can use the square root property to find solutions. Square root of a negative number gives you an imaginary unit. If it's nice, you can factor it, so you don't even need the square root property, right? We know that. Everyone should review this. If you had trouble there especially, there's a lot of problems there, but it's not actually a bad problem. I think you guys did better on that on the test than you did on the quiz, if I recall correctly. This one here. So for a problem involving radicals, what's the one piece of advice I have that you should focus on? Isolate the radical before you square it, right? So if you need to add things or subtract things, do so. Make sure that your square root is on its lonesome so that when you square it, you just square the square root and you don't have to like distribute things around. Some of you did this wrong step of just squaring it, but you're assuming you can like square that and then subtract the square of that and set it equal to 0. That is not how algebra works. If you square this as it stands, you get cross terms because it's like a minus b squared, which gives you a squared minus 2ab plus b squared, actually. So we have to isolate the radical then square, okay? And if you do that, it still gets you to this ugly quadratic equation, but we know the quadratic formula for this kind of problem, so there it is, all right? If we have an absolute value equation, we expect two solutions, right? The other thing we haven't done in quite a while is inequalities, right? But those should be on the final. If we have a rational inequality, what do? We pick the critical numbers, we put them on the number line, we test cases, right? Remember the sign flip theorem? If we have an even power, it doesn't flip signs. But if we have an odd power, like we do with -3, 5, and 8, we go plus to minus, minus to plus, right? As you go across the critical numbers. Now we're solving greater than or equal to 0 for this problem, so we look for the pluses forming our solution. So -3 to 5, and then 8 to infinity. And then like, what's up with this? Well, why is there -7 here? Because we're solving equals 0, right? So if you have -7 or if you have -3, we've got 0. So that's why -3 is included here and why I have to add -7 over there. Also, why is 8 and 5? Why are they not in the solution set? Because what happens with 8 and 5? A bad thing, right? Division by 0. So that means that we can't do that. Therefore, I have to exclude those from the solution set. What are the 3 things in here that we cannot do in terms of like formulas? Do you know? What are the 3 things? The one is divide by 0, right? The other is take the square root of a negative number. Now, these 3 things I'm telling you, they're if we want to keep it real, all right? We can take the square root of a negative number if we're looking for complex solutions to quadratic equations, right? I just had it on the previous page of this test, right? But that's the sole exception. The other thing is natural log has to have positive inputs, right? We can't take the natural log or any log of a negative number, right? So those are kind of the 3 things to look out in terms of domain. Are you guys comfortable with these? Do you remember the big idea? There's like 2 main things to look out for here. So here's the 2 patterns. For B positive, if we have absolute value of absolute value of A less than B, that unwraps as minus B less than A less than B, this compound inequality. But if we have absolute value of A greater than B, that is equivalent to A being less than minus B or A being greater than B. So there's an asymmetry between the case of greater than and less than, right? Like I use this way of thinking for part B, right? And I have to use this way of thinking for part C because this is a less than problem and this is a greater than problem. See, there's a very big difference between these 2 patterns. And you see the solution bears that out, right? We have one interval as our answer. We have a pair of rays that we have to union together as the answer there. So that's always a struggle for college algebra, but if you can master these 2 problems, then you're probably going to be okay on that problem. If you can really do these without looking at the solution, you're probably okay for that. Oh, I always forget about this, but parallel line has what? Same slope. Perpendicular line has what? Negative reciprocal slope. That's basically it. So I have slope -4, so the parallel line has slope -4. The reciprocal line has -1 over -4, which is 1/4. And I'm using the so-called point slope formula for the line in both of these. But let's see here. Let's move on to test 2. If I can find it. So test 2, let me skip over the part that's not, let me just get straight to the part that'll give you guys trouble. So I think we talked about this a little bit already, right? Like, what's the difference between problem 2 and what I had on the sideboard a second ago? The difference is the leading coefficient here is 1, which makes it a much more friendly problem. So you don't face that confusion between the -11 versus 22 on the y-coordinate of the vertex, right? Like there's no number to factor out or to multiply through again. You can just see it directly. The vertex is at 3, -2. And you're right, there's an asymmetry here between other formulas in the sense that I don't change that -2 to +2, right? The way that the 2 is associated to the point is different than like the way like the center of a circle is associated to the circle equation. In the circle equation, there's a minus for both pieces, and you have to adjust the sign. But here, the one is to do with x, and the other has to do with y, and that's why there's a difference. But anyway, remember, if we complete the square and we don't have a square, we can still factor. We just use square roots, right? As long as it's minus. What happens if it's plus? Then we can't factor unless we use complex numbers, right? In which case we say that the polynomial is prime. Let's talk about problem 3 for a minute. So problem 3, we have something like this. What's our first order of business is to factor, right? We factor, and then we look, is there anything common? Well, there's a common x minus 3 above and below. Same order, which means it's a hole in the graph. The x plus 1 upstairs tells me there's an x-intercept at minus 0, minus 1, 0. The x plus 3 downstairs tells me that when I plug in minus 3, it blows up, right? So it's a vertical asymptote there. And the hole in the graph is at 3 because we've got this balanced pair of factors. And to figure out where the hole is, we cancel these out, and that leaves us the reduced function, which is x plus 1 over x plus 3. And then you plug 3 into that, which gives you 2/3 is where the hole is. So if you're confident about problem 3, if you understand, if you really understand problem 3, then that's a good chunk of the graphing rational functions idea. The other chunk, of course, is over here, this problem 5. By the way, problem 4, a lot of people got wrong, and you got it wrong on the quiz, and you got it wrong again on the test for various reasons. It would be wise for everyone to study problem 4 and see how you got it wrong. It's something you can fix, this one, all right? So just take a look at that for yourself. Problem 5. So here, this was the test problem. A lot of you put horizontal asymptotes at minus 2 or 2 or something here. Or some of you put a horizontal asymptote up at like 12. I forget exactly. There was a lot of different answers. But the key idea here is just this. If we have degree 2 downstairs and we have degree 1 upstairs, then the horizontal asymptote is just y equals 0, right? The difference with the quiz problem, if you go back and look at it, so here's the quiz problem. What was the difference? In the quiz problem, we had order 2 upstairs and order 2 downstairs. So they matched. And when the orders are equal, then the leading coefficient ends up giving you the horizontal asymptote, which in this case was minus 2. All right? So you have to think through it. Don't just assume it's the same as one or the other. You have to actually, think through the horizontal asymptote issue. There's a few different rules we discussed in class. That said, easier things to notice is if you have division, if you got division by 0, you're going to have a vertical asymptote there, right? Like at minus 6, at minus 4. If there's this upstairs, if there's an x plus 2 squared, that means it's going to bounce at minus 2 like it does here. That was the quiz problem. On the test problem, the graphing was different because there was no bounce, right? Every factor is just linear, which means you've got a crossing the x-axis at 2, but you've also got the sort of vertical asymptotes. Well, my brother says that these vertical asymptotes cross at infinity. I don't know if you want to believe that or not, but these sorts, not volcanoes, but they look like this. Now, I think I had a volcano in like your multiple choice, the multiple choice part, right? Was that there? Yeah, right here. Like part D is when we have a square downstairs, we get a volcano, in this case upward. All right, let me get back to test 2 here. Wait, that's not test 2. Is this test 2? No, that's test 1. Is this test 2? Where's test 2? Oh, here it is. Duh. All right. Another thing we should remember is the factor theorem. There are 2 versions of the factor theorem. The most basic version is just this, right? If you have f of c equals to 0, that's true if and only if x minus c is factor, right, of f of x. That was one version of the factor theorem, and so I used that in this problem twice, right, to get a factor of x minus 1 and to get a factor of x plus 1. But fun fact, if you have 2 factors, then the product of those factors is also a factor, and that's convenient because if you want to like factor that out, using factor so many different ways, we can use long division to find the cofactor of x squared minus 1 for this quartic. And I do that, and so that tells me that x squared minus 1 times that is equal to this f of x. And then, of course, I can unmultiply what I've multiplied, right? Like this, in fact, factors x plus 4 times x minus 3, and I'm just undoing the multiplication that got me to x squared minus 1 there. And there you go, it's completely factored. How do you know when your polynomial is completely factored? It's when you've got either linear factors or what? Or irreducible, or prime quadratics, right? So the prime quadratics come with complex zeros, right? If f of alpha plus I beta equals to 0, that's true if and only if x minus alpha squared plus beta squared is factor of f of x. So that's something some of you have learned and some of you are still learning. But that was important for doing like problem, let me go skip ahead here for a minute. Problem 9, well, not, okay, well that was not the one. Just a second here, I'll find it eventually. I think it was on the quiz. So yeah, like problem 7 on the quiz 2, I gave you that you had a complex 0 and a real 0. So the thing is, the complex zeros theorem says that f of 1 plus 2y gives you a, a hand. There we go. Gives you x minus 1 squared plus 2 squared, which is 4, and you multiply that out. So you've got this x squared minus 2x plus 5 factor. X of 5 equal to 0 means x minus 5 is a factor. You're looking for a cubic, which is third order. So if you've got these two are factors, you're pretty much done, because the only thing else that you're left freedom to add is just a multiplier. And then that multiplier is fixed by the fact that I gave that the y-intercept was 50, which makes the multiplier minus 2. And then the really annoying part about this problem was I asked for standard form, right? Which standard form means what? That means that you write the polynomial as either ascending or descending powers of x, which is obnoxious because that means you actually have to multiply these things out, right? That's the only place where that has happened, I believe. All of the other questions I've ever asked you guys on quiz or test, I have allowed the answer to be not multiplied out, right? As far as I can think of, like this one, for example. Remember this one? We have a crossing at 6, a crossing at minus 6, a crossing at 4, a bounce at minus 2, which forms, this is my template. So I do x plus 6 to get the crossing, x plus 2 squared to get the bounce, and x minus 4 to get the crossing. I also know that f of 0 is minus 48. That allows me to fix the value of a, and there's your answer. Did I multiply it out? I did not, right? And most of you have not done that this semester, so hooray. You can contrast this problem with the one that was on the test, right? Which was what? This one here. What's the difference? This one doesn't, the other one had 2 crossings and 1 bounce. This one has what? 2 bounces and 1 crossing. So the 2 bounces, I have the squares for the crossing, I just have first order. And again, the multiplier we figure out from where the y-intercept is in this case. So yeah. And then, you know, the other thing I would say is if you're rusty on the long division, make sure you practice that. There will almost certainly be a long division question on the final. You know, the part B here, right, this is, I would say that this is bonus. So like this was a kind of sneaky calculation. The point of this problem was that if you factor out this x squared minus 6x plus 10, it gives you this formula. But the thing about x squared minus 6x plus 10 is that when you plug in that complex number, you get 0. See, because this is the quadratic which takes 3 plus I as its complex 0. So that makes this term 0 when you plug in 3 plus I, as I show down here. So all of this mess is 0 when you plug in that complex number, and all that's left is this over here, which makes calculating f of 3 plus I actually pretty easy in the sense that you just basically focus on the remainder term and it gives you 4 plus 3i. I did have a person in some section actually plug the 3 plus I into the quartic and like just work it out brute force and you'd get this. But that is definitely not the way you want to do it if I was to ask it again. And I might not. I wouldn't assume I'd ask this again. So, any questions? I think that's pretty much all I got to tell you guys today. So I guess that's it. So see you at the final? Yes? No? Maybe so?